Hello and welcome to my video presentation for the ENY2890 class. My name is Carson and let's go on a little bit of a journey through time, shall we? So, the paper that I chose is titled A Primitive Honeybee from the Middle Miocene Deposits of Southeastern Tunan, China, Hymenoptera apidae, by various authors, Engel et al., and it was published in Zookeys, which is a peer-reviewed open source journal in July 19th, 2018. So for me, and for most of the class, we are not entomology majors, so I felt it fitting as a geologist to pick a paper that falls under my field of study, or one of the various fields, as there are multiple within geology, specifically paleontology. So personally, I am not a paleontologist, but I have learned a little bit about paleontology, but I'm no expert in it like some of my colleagues. However, being the only geologist in the class, I think it's important, based on some of the terminology used in this paper, to give a little bit of a background for everyone else. So, this is the geologic timescale. Now, it is very important and used all the time by geologists like me. This is the more unfun version, you could put it, that I have to use. And pretty much as geologists, the Earth is 4.6 billion years old. We have been able to put these into categories based on eons, eras, periods, epochs, and ages. So there are four main eons: the Hadean, Archean, Proterozoic, and the Phanerozoic. Now, all of this is the Phanerozoic, and you would think that it's a lot of time, whereas in reality, on the more fun version that most people can use, here's the Hadean, Archean, and Proterozoic. So you see from 4.6 billion years ago to about 541 million is part of all these eons. And what's even more important is that you look where animals started. That's at the very end of the Proterozoic. And then land plants didn't even show up until the Paleozoic, around 541 million years ago. So, relatively speaking, the history of the Earth has been very long, and we have only been part of a very small sliver of it. Specifically, hominins are just this tiny little line right here, about 2 million years ago. So, just a little bit of background information, because again, they do use some terminology from the geologic timescale, and a lot of people are actually not familiar with it. So, this paper was put into 4 different sections: an introduction, a materials and methods, section that is the results, but they didn't call it the results. It's a little bit different for paleontology, and then a discussion section. So, starting off, let's hit the introduction. So, similar to most bees, the fossil record of Apidae is sparse and it's mostly confined to the Cenozoic, which is about 66 million years ago to now. So we're living within the Cenozoic right now. In Asia specifically, honeybee fossils are relatively uncommon. They are actually much more common in Europe, and that's where most of our records come from. So within Asia, honeybee fossils have been mostly confined to Shanwang. Excuse me, I don't speak Chinese, so some of my pronunciations may be off, but that's within northeast China. So this new fossil that this paper is talking all about, because it was a new discovery, this species belongs to Sinapis, and it expands the geographic and temporal distribution in China. And it moves it farther south, and it becomes about 1 to 2 million years younger in age than they actually thought was around in China. So, let's move on then to the materials and methods. So, the fossils were collected from the northwest Maguan Basin. That's located in Yunnan, China, which is part of southwest China. There are 3 main sediment deposits. I'm sorry for a minute, this might be a little boring, but these are the geological stratigraphic layers. Some of you might know what I'm talking about. I'll try to describe it as best as I can. So they're all Cenozoic in age, which means they're all 66 million years old or younger. So the Yanshan group is Paleogene in age, which is about 66 million to 23 million years old. The Hoesig Formation, which is Neogene in age, which is about 23 million years old to present, and then Quaternary deposits. So those are Quaternary in age, which is any sediments that are less than 2.58 million years old. So the geologic composition of all of them, so for the Yangshan group, they're quartz breccias and they lack fossils. Breccias are a type of sedimentary rock. Then there's a layer of unconformity, so there are missing layers or missing geologic time within them. And then this is the basal group, so on the very bottom. So then the unconformity happens, and then the Hoesig Formation is right above it. So that's a fluvio-lacustrine deposit, which means it was deposited by both river and lake processes. They are politic laminated siltstone and mudstone, so very fine-grained sediments, and it means it was also a very low-energy environment. And there are abundant fossils within this layer. On top of this, then, there's another unconformity, so more missing time, and then there's the Quaternary deposits. So Quaternary deposits is just a general term that we use in geology, and that describes newer, relatively, right? They're 2.58 million years old or less, but in geologic time, that's very new. And most of these sediments that are unconsolidated because they haven't had enough time to compact and cement together. So these are the three main layers that are found in the Maguan Basin, and mostly we're going to focus on this one right here, the Hoesig Formation. So let's look at the first figures 1 through 3. They put them nicely in these composite pictures for us. So right here is where the insect fossil, specifically the honeybee fossil, was found. So throughout this whole layer, you can see it here. Here's a cross section of it, right? So there's a highway that's going through this way. They're mostly then these mudstones and sandstones that are interbedded. So that means then it was very fine-grained and it was a very low energy environment, which is good then for preserving some of these fossils, like this plant right here. So you can see right here is about where they found the insect fossils within this layer. And so in the bigger, broader, normal scale of things, you can see that on this entire face, they found it right about there. Lots of looking when you have to go on a rock face like that. So the layer where this fossil was found is the Hoesig Formation. So this is Middle Miocene in age. So the Miocene was about 23 to 5.3 million years ago. So it's about within the middle of that, and that's based on paleomagnetics. Pretty much, paleomagnetics are some minerals have magnetic properties, and so when they are first formed, then they align with the poles, and then the North Pole and South Pole flip every 100,000, 200,000 years or so. So what they do then is they flip, and you can tell then relatively based on age when it occurred, because we have records specifically on the seafloor of when this happens. So these sediments that are located in this deposit have abundant insects, fish, bird, and plant fossils within them. This indicates then that it's a subtropical evergreen environment, and it makes it warm and wet, which is perfect then for preserving fossils as well. And then mainly then the photographs that you'll see in a bit were taken with a Zeiss Stereo Discovery V16 microscope system. So the results section, it's actually systematic paleontology. So let's talk about then what they found. So here's figures 4 to 7. So this is the actual fossil that they found. Now it is carbonized, so this is not actually the color that it would have been and everything. It's actually, this is more of a light brown, this is a darker brown that they describe. But you can clearly see in its ventral orientation, the wings are put out. You can't really see the stinger, but they assume that it's there. You can see the head, it is slightly tilted, and then they were able to reconstruct both the forewing and the hindwing, which is important for later. So, here's another figure specifically of the wings up close, so you can really see it's actually very well preserved, especially for insects being soft-bodied. organisms very hard sometimes to create fossils from them. So, this new species is similar to Miocene honeybees from Shandong province. Apis delica differs, though, with an arched basal vein within the wing. So based on the fossil, the honeybee is a worker. It's about 17.06 millimeters in length. So the forewing has venation typical of Apis and the corresponding subgenus Sinapis. So the forewing is 8.54 millimeters in length, 2.18 millimeters in maximum width. The hindwing also has typical Apis venation. It's about 6.37 millimeters in length, 1.39 millimeters in maximum width. So, let's move on then to the discussion portion of it, which is talking a little bit about what we see in this. So, honeybee fossils, again, are very uncommon in Asia, so it's important to remember how rare that this fossil actually is. And compared to the amounts found in European sedimentary sediments, specifically in the Oligocene and Miocene. So before now, most of the fossils in Asia were found in the Shandong province, and it's difficult to comprehensively understand apine diversity in Asia due to the lack of fossils that they've found. So this discovery then expands the known regions of fossil honeybees southward in China. And this is also hopeful for the future now that they found it in a different region completely across the other side of China from them, that there could be more exploration and it could spark interest to go out and find these more. And here is the work cited for the paper itself, and then the lovely GSA geologic timescales that I used for those pictures. And thank you for watching my presentation.